If we ask AI what Pluto looked like in the past, it'll show volcanoes spewing water instead of magma and an ocean full of fantastic life forms from horizon to horizon. And this is consistent with scientific evidence. That's exactly what Pluto could look like just a few billion years ago. But over time, the planet's interior was running out of heat, and the energy from the sun wasn't enough, so Pluto got covered with ice, but not completely. There is still a liquid ocean beneath the planet's outer icy crust, and there are active volcanoes on its surface. And it looks like Pluto will soon return to its original form, perhaps it'll even develop life again. But to imagine what it would look like, we need to figure out what Pluto's hiding from us. Pluto was formed about 4.6 billion years ago, roughly at the same time as Earth. Now, its area is almost the same as that of South America, but previously it was 2.5 times larger and almost completely covered in liquid oceans. But we know that Pluto's located 40 times farther from the Sun than Earth, and the existence of a liquid ocean on it defies logic. To find an explanation for this, we'll have to look far back into the past, namely the moment of the solar system's formation. Scientists claim that the planets in our system were formed in the protoplanetary disk that surrounded the early Sun. And it's not just called the disk, it's a flat ring of matter that orbits a star. Consequently, the orbits of the planets formed in the solar system are approximately in the same plane. And this concerns all the planets except Pluto. The thing is that after their formation, planets could change their orbits. Scientists believe that Jupiter, Saturn, Uranus, and Neptune formed much closer to the Sun and over time moved away from it. But as Neptune was moving away from the star, several light objects, including Pluto, were grabbed along for the ride. As a result, Pluto was much closer to the Sun at the time of its birth and could get enough heat from it to form a liquid ocean. At the same time, Pluto's atmosphere was 40 times denser than that of Mars. Now it's 100,000 times weaker than Earth's atmosphere and appears only in the summer when the planet gets closer to the Sun and the ice starts to evaporate. The almost total absence of an atmosphere prevents liquid from forming on Pluto's surface. But Neptune was not the only one to affect this dwarf planet and forever changes conditions. Another disaster for Pluto was the appearance of a satellite, Charon. Charon is only about half Pluto's size, and the same side of Charon always faces Pluto. In this system, it's not the satellite that revolves around the planet, but Charon and Pluto orbit a conditional point, the barycenter, together. Charon formed 4.5 billion years ago, just 100 million years after the appearance of Pluto. Back then, one of the Kuiper belt objects hit the planet at tremendous speed. Scientists suggest that the proto-Charon collided with the proto-Pluto to form the famous Pluto's heart, Tombaugh Regio. That's a zone of nitrogen-rich glaciers stretching over 1,500 kilometers. Researchers say that a few billion years ago, there was an ocean of water, the proto-Charon hit it, displacing some of the fluid and forming a huge satellite. Therefore, Charon is mostly covered with water ice, and Pluto is covered with nitrogen ice as a result of this collision. Pluto literally rotates on its side, its actual tilt is about 120 degrees. For comparison, Earth's axis is tilted by only 23 degrees. Due to this, at the poles of Pluto, the change of day and night occurs once every 124 Earth years. But these aren't all of the consequences of the collision with the proto-Charon. In 2011, a team of Brazilian researchers calculated that a ring system could form around Pluto. Its rings were supposed to be 750 times smaller than those of Saturn and much fainter. The simulation results of 2013 showed that, in addition to the rings, Pluto could also have about 10 satellites. But after the New Horizons probe sent back the images of the planet in 2015, scientists were shocked. It turned out that there are no rings or new satellites in Pluto's system, only the previously discovered Charon, Nix, Hydra, Kerberos, and Styx. Principal investigator for NASA's New Horizons mission, planetary scientist Alan Stern, believes that the absence of rings and new satellites is the most surprising discovery of the mission. But if NASA managed to take ice samples from the surface of Charon or Tombo Regio, we could make a more sensational discovery. After all, if the ice on the satellite was once a liquid ocean on Pluto, there could be traces of life. And we have reason to believe that, in the future, we'll see not just a relief area that looks like a whale, but real red whales on the planet. Today, the opportunity to take a closer look at Pluto presents new mysteries to scientists. For example, look closely at this area. Have you noticed oddly shaped fractures? That's the so-called ice spider, one of the unusual geological areas on Pluto. The longest of these fractures are aligned roughly north-south of the planet and reach 580 kilometers in length. Strangely enough, this spider resembles similar formations on Venus and Mercury, the closest planets to the Sun. Scientists believe that the fractures on Pluto are caused by the fact that its crust rises as a result of heating, as if a volcano had formed there and magma made its way out, lifting soil layers. But there's no hot magma on Pluto, so there can't be any volcanoes. Or am I wrong? This photo taken by New Horizons clearly shows the mountains in the southwestern part of Pluto's Sputnik Planum. At least two of them, Wright Mons and Picard Mons, are actually volcanoes. Although the average temperature on Pluto is minus 232 degrees Celsius, so-called cryovolcanoes can form there. They spew not molten magma, but a mixture of water and nitrogen ice, the consistency of which resembles toothpaste. Pluto's largest volcano is Picard Mons. Its height is almost 7 kilometers, and the width of its crater is 225 kilometers. It's almost the same size as the largest volcano on Earth, Mauna Loa. At the same time, Pluto is 6 times smaller than our planet. Scientists believe that these cryovolcanoes formed 2 billion years ago, but the last eruption on Pluto happened quite recently, by space standards, only 100 million years ago. But even this is not the weirdest geological phenomenon on the planet. In the western part of Sputnik Planum, Pluto's surface literally turns into a lava lamp. These ice cells, ranging from 16 to 48 kilometers in diameter, are in fact constantly moving. They're covered with rough nitrogen ice along the edges, and in the center, they're perfectly smooth. That's because the solid nitrogen is warmed by Pluto's internal heat, becomes buoyant, and rises up to the surface. There it lifts the ice layers before cooling off and sinking again. These cycles are repeated every 500,000 years. Active volcanoes, fractures on the planet's surface, and churning ice, all these indicate that Pluto is heating up. But what could possibly heat this planet up? Pluto is tremendously far from the Sun, almost 6 billion kilometers away. Light takes 5.5 hours to overcome that distance, and the brightest day on the planet resembles a full moon night on Earth. However, Pluto is still exposed to intense solar radiation. The thing is that the planet's atmosphere is very weak and does not protect it from exposure to sunlight. Therefore, you can find strange landscapes there. For example, unusual mountains resembling snakeskin or rocks similar to bite marks. Such relief is formed just because of the sun's influence. The ice that makes up mountains and rocks doesn't have time to melt and turn into a liquid under the influence of sunlight. Instead, it immediately evaporates and leaves strange patterns on Pluto's surface. But even though the sun can change geological landforms on Pluto, that doesn't explain how a liquid ocean appeared on the planet. According to scientists, a liquid ocean of water could have been lurking beneath Pluto's surface for billions of years. You see, at the time of its formation, the planet was not as cold as it is now. Once Pluto was formed, its core could have undergone radioactive decay. It heated the planet from within and formed a liquid ocean of water beneath its surface. Scientists suggest that this ocean's layer may reach 150 kilometers in depth and exist under a crust of ice up to 300 kilometers thick. Over time, the planet began to cool, and the ocean partially froze. The point is that when water freezes, it increases in volume. Thus, if you put a bottle of water in the freezer, it can burst. That's roughly what happened to Pluto. Do you remember the ice spider? Possibly these fractures in the crust were formed just because of the partial freezing of Pluto's underground ocean. Besides, the craters on Pluto don't look like they should. When a meteorite hits an icy surface, it leaves a smooth and sharply outlined bowl-shaped depression at the impact site. Most meteor craters on Pluto have an uneven edge, as if something had stretched them. But that's not all. Scientists have circumstantial evidence that the underground ocean is not entirely frozen. Geological activity can still be observed on Pluto, and it's not just cryovolcanoes, there are also floating hills. These solitary formations of solid water ice literally move across the planet's surface. These hills are only about 500 meters high and are located on the nitrogen glaciers of Tomba Regio. Scientists assume the hills freely slide across the surface because the ice under them periodically heats up and moves. This means there may still be a liquid water ocean in the depths of Pluto. And the thing that doesn't let it freeze completely is Charon. Pluto and Charon can be essentially regarded as a double planet system. The distance between them is 19,500 kilometers, 20 times less than the distance from Earth to the Moon. Consequently, the tidal forces affect Pluto more, and the planet is exposed to tidal heating. In simple terms, orbital rotation creates friction in Pluto's interior and heats it up. That's not enough to turn the dwarf planet into a habitable world, but the heat may well be enough to maintain a subsurface ocean in a liquid state. And where there are oceans, there may be life. And as strange as it sounds, Pluto has the right conditions for that. The proof of this is Pluto's red whale. No, not this one, but Cthulhu Macula, the region near Pluto's white heart. Its length is almost 3,000 kilometers. The entire area is covered with unusual red deposits, hence its second name, red whale. Scientists believe that Cthulhu Macula formed after Charon. Hidenori Genda, an associate professor at the Tokyo Institute of Technology, conducted computer simulations of the Proto-Charon's giant impact on Pluto's surface. According to his calculations, after a collision of such force, the ocean along Pluto's equator warmed significantly. Over time, it began to cool, and complex organic materials formed on its surface, giving the whale its dark red hue. These compounds are called tholins. They can be formed from methane under the influence of ultraviolet radiation from the sun. Some scholars call tholins the chemical precursors of life. In 2009, a group of scientists led by Professor of Astrochemistry Sergio Pilling from the University of Paraíba Valley in Brazil published the results of their experiment. Researchers irradiated tholins with X-rays and noticed that as a result, they received adenine. This substance is one of the constituent elements of DNA. Stolons with X-rays and noticed that as a result they received adenine in this substance is one of the constituent elements of DNA. Just imagine if Pluto had a suitable temperature, we'd find life there. For Pluto to form ideal conditions for the emergence of life, we need to inflate the sun as much as possible. Now it's a dim yellow dwarf, but in a little more than 1 billion years, the star's luminosity will increase by 11, and in 7.5 billion years, the sun will grow 200 times its current size and become a red giant. By that time, it'll expand into Saturn's orbit, and there will be nothing left of Earth. Well, on Pluto, the temperature will rise to a comfortable 20 degrees Celsius. Since Pluto's gravity is 12 times less than Earth's, it'll be difficult for it to form a stable atmosphere. And even though over time, the gas will no longer escape into space, the pressure on the planet will be much lower than Earth's. Keep in mind that Pluto rotates virtually on its side, and its polar nights last 124 years. This means the temperature there can drop to a critically low level. But given that more than 80% of the planet's surface will likely be covered by water, the temperature there will be stable due to low gravity and rarefied air. Birds and other flying species are unlikely to survive on Pluto, their wings just wouldn't be able to keep them in the air. And land animals will have lighter, more flexible skeletons because of the scarcity of land. Herbivores will hardly be able to survive on Pluto, but predators will thrive. For example, local bears could feed on smaller fish and predators. Due to low gravity, jumping will become the most convenient way to move around. So the structure of the hind legs of bears will resemble kangaroos. In addition, land animals on Pluto won't need ears. That's because sounds in a rarefied medium propagate much slower. Most likely, the locals will rely more on their sense of smell and sight. Although due to Pluto's size, the visibility range will be less than on Earth, objects in the distance will be seen very clearly. That's because in the rarefied air, they won't be hidden by haze. In addition to bears, small ambush predators can also be found on land. For example, Plutonian wolverines. Their fur will be greenish. The thing is that the atmosphere on the planet is nitrogenous, and that means landscapes will look green even without the plants we're used to. And wolverines use this feature to disguise themselves and hide from other predators. The animal will move quickly, not only on land but also thanks to a leather membrane between the fore and hind limbs. It'll be able to leap from a hill and glide through the air. The gliding membranes will also help wolverines swim faster. The first skill will come in handy to escape from a Plutonian bear, and the second will help them hunt fish. Most likely, land predators will descend into a deep dormancy called stasis to survive the long polar night. After all, their underwater prey migrates to the planet's bright hemisphere, and the temperature will drop below zero. But it doesn't mean the land will remain lifeless. At night, ice spiders will take over the land. Unlike Earth spiders, they won't spin webs on Pluto. These insects are scavengers and feed on the remains of other animals. But the planet's polar night lasts more than 100 years, and the spiders will quickly run out of food. Thus, the scavengers will turn into predators. Their sensitive eyes and antennae on their paws will allow them to find burrows of wolverines and dens of sleeping bears. Then the spiders will gather in groups and inject the victim with immobilizing poison so that they can then eat it. But the greatest diversity of life on Pluto will undoubtedly be found underwater. In the course of evolution, the local fish will acquire special gas-filled sacs. When a fish spots danger, it'll immediately release the contents of the sacs through special tubules on its body. That'll give it the necessary acceleration to escape from the predator. But most carnivorous species in Pluto's ocean will hunt from ambush. For example, Plutonian sea anemones. They attach themselves to rocks and shoot immobilizing poison at their prey passing by. Then they extend their long tentacles and pull the prey towards them. But some predators don't need such tricks. These are Plutonian red whales. Additional fins make these enormous underwater animals very maneuverable, and a few rows of sharp teeth leave the victims no chance of escaping. These whales are solitary, but during the breeding season, they gather in small groups and hunt in turn, sharing their prey with other whales. Baby red whales are very vulnerable, so they're under the protection of the group until their fins get stronger. In 7.5 billion years, the conditions on Pluto will be just as favorable as they were back when it was formed. And perhaps this dwarf planet will be inhabited not only by animals. When the sun becomes a red giant, our Earth will cease to exist. Expanding, the star will just absorb it along with other planets. But humanity will have a chance to survive if we relocate away from the sun to Pluto. I wonder what our life will look like there. What do you think?